So basically, this is friction. What is friction? Friction is basically the force which opposes the motion or the tendency of an object to move relative to another object or surface is basically called as what? Friction. Always remember, friction always opposes or tries to oppose the relative motion between the two surfaces slash objects in contact with each other. Friction is the contact force, grade 8. Everyone remembers, right?
Yes. Yes.
Yes.
Now, based on the opposition process, friction is divided into two parts. So based on the opposition process or the surface involved, friction is classified in two types. First is dry friction. Dry friction is basically when two solid surfaces are in contact. Guys, dry friction is basically when two solid surfaces are in contact, then the friction between them is basically dry friction, right?
Yes.
And what is another type of friction, which is basically called as wet friction? What is wet friction? It is either in between one solid and one fluid surface. What is fluid?
Liquid.
Liquid and gases, some gases. And there is one more, which is two liquid surfaces. Wet friction. Okay? Please remember, this is in between this is in between this. This is due to the irregularities of
So, sir, 8:30 is the result tomorrow.
what?
AM.
What?
8:30 AM is the result.
8:30 नहीं होना चाहिए ना? If it is
No, it's
11
not
a.m. in
8:30.
Indian time, then it should be 9:30.
To the minister of something, he tweeted it that the results will be declared tomorrow 10 a.m. IST. All the best.
अच्छा 10 a.m. he said. So it's a
10
good
a.m.
thing.
हाँ,
ठीक
10
है.
a.m.
तो फिर 8:30 बजे से I don't think you people will be awake by that time. Chidi, are you awake?
Yeah, when we wake up for the extra class with.
Abhi, once those extra classes will be over, then you people will sleep till 10 a.m. I know.
Yes, sir.
Yes, sir. I know.
The extra classes are there. Still, I sleep at 11:50, sir.
Yeah, even I wake up at 11:50.
Why? How? You don't attend the extra classes? Okay, you just
The extra
open
classes
your.
at 12. No, extra classes at 12.
Oh, okay. No, not those extra classes. I'm talking about the extra classes in school.
So we don't have school extra classes.
They only give it during 12th and 10th. They don't give it in 11th and 9th.
Yes, sir.
Arey nice.
Yeah.
Chalo, this is nice. So
Sir,
that
our
is why
school gave for 11th grade as well.
Oh my God.
Our school closed early and they're opening on September 1st. No teaching in between.
Nice.
Hello. It
It was like 1 week early or something.
Guys,
Yes, sir.
please write
Yes.
it down fast. Basic definitions.
Done, sir. Dry friction.
What we need to learn in this chapter is basically this dry friction. The
Friction.
friction. The friction which we are learning over here is basically between two solid surfaces in contact. This is not discussed in this chapter. Please remember. Okay?
Sir, wet friction is basically negligible, right? Then what is that to study in?
It is not negligible once you do something. मैं बताऊंगा बाद में. Don't worry. I'll give you some questions which is based on those. So, anyways, once you're done writing, just tell me. Then we'll start.
Sir, can't dry friction also happen on a smooth surface?
Yeah, it can happen, but very smooth surface, if you place very too too highly smooth surface in real cases, then the friction between them becomes infinite. In real cases, not in ideal cases. If an ideal case, if you have a surface which you have polished so much that you try to the friction on it becomes zero, almost zero. So if you place two surfaces like this together, then the friction between them becomes like infinite. I'll tell you the reason also for this later on.
Meaning the friction is very much or not
Yes,
at all?
they will just like it will be like sticking together to each other. They will not move over one another. They will just stick to each other.
How is that possible, sir?
I know. Anything is possible.
What?
Yes. Chala.
Sir, how is flat and flat sticking together so attractive?
Because achal मैं reason बताता हूँ. Because it's like when you make a surface too much smooth, then the molecules which are there on the surface, they come too much close to each other. So when the molecules which are there on the surface, the atoms which are there on the surface, right? Atom of surface 1 and atom of
Yes.
surface 2 will come very close to each other, due to which they will develop a bond between them. Very weak bond, but there are millions of molecules inside that. So that force will be something, right? So it appears to be like two highly smooth surface, they stick to each other. Are you getting my point? So always remember,
No,
whenever
sir.
it is like
I didn't get your point, sir.
Yeah. रुक जा 2 minutes. रुक जा. We'll come back to your
रुक रहा
point.
हूँ,
है ना?
sir. Waiting,
We'll
sir.
come back to your point. है ना?
Yes, sir.
Let's start. First, let's talk about what is the cause of friction. Then we'll come to Cyril's point as well again. So suppose if there is one surface over here,
But not so smooth.
yeah, it's a rough surface, and there is a block placed over here. Please don't think like NLM will leave you in the previous chapter itself. No, it will not leave you to a 12th grade. So guys, suppose if can you see the contact is there in between these two blocks, between this point? Can you see from here to here there is a contact, right?
Yes, sir.
So whenever there is a contact, let me just zoom in for you. If I zoom in, oh, Lord.
Could you scroll a little up to see second point of wet friction?
Sir, actually, you are just drawing a triangle. You're not really zooming in, are you?
What are you saying exactly?
Could you scroll up after the
Nothing,
second
sir.
point?
Never mind. I was just joking.
So due to continuous collision of medium particles in body. Yeah, fine, sir.
So basically, can you see this part? This much surface, I am zooming it for you. Okay. So if I say this is the body and let's say this is the ground, then when you zoom in, will you be seeing the surfaces like this?
Of course.
There will be certain irregularities, right?
Yes.
Yeah.
So when they brush against each other, one particle will start stopping and so on.
This is the body and this is the ground. So basically when this block is placed over the surface, then this block and the surface, can you see there is a contact between various points? Can you see there is a contact over here? I'll just draw this like there is a contact. If there is a contact, there is a normal reaction. So normal reaction in the opposite direction. Can you see small normal reactions? Guys, can you see small normal
There is the body in motion.
No. Abhi not
But
now.
is at rest.
No, abhi everything is at rest.
Okay.
Okay. So at different points, can you see the normal reactions at different points wherever it is in contact?
Yes.
Yes or no? So basically you need to draw like this exactly. Always remember the direction of normal reaction should be equal and opposite on both the cases. Can you see N1, N2, N3, N4? So N1, N2, N3, N4.
Sir, what do those black arrows?
They are the normal
represent?
reaction at various contact points.
Meaning?
The normal reaction, wherever the body is in contact, there is a force of normal reaction, no? Reaction force.
I didn't get it, sir. What is normal reaction thing?
What is normal reaction? Whenever there is a body placed on a surface, does it experience a normal reaction? N. ये याद है?
नहीं, sir.
अरे?
Away from Newton's law of motion.
From NLM, normal reaction.
Wait a second. Oh, okay. Right.
So that normal reaction is basically acting at different point. But if you draw the tangent over here, the tangent will be like this. So that is why the normal reaction is a little bit teda. Can you see different normal reaction in different direction, right?
Yes.
Okay. So now I'll tell you the reason why there is this normal reaction as well. So can you see the microscopic, when you go to the microscopic view, the body and the ground has irregularities on their surfaces in shape of crest and troughs. You understand what is crest and trough, right? The mountain like structures are crest and the valley like structure is basically troughs, right? Yes or no? These irregularities are basically, can I say, surfaces are rough due to which the contact between the body and the ground is made only to some points at these points. There is a reaction force, or you can say it a local reaction force, because different points there will be different reaction forces, right? So there is a local reaction force at these points in a direction perpendicular to the surface at the points of contact. Is there anyone watching movie? हाँ लिखना है, ये cause है उसका, इसका, you know, once you do that, now we'll come back to these forces now. So basically what are these forces? These N1, N2, N3, N1, N2, N3 are basically what? Their local normal reaction, or basically the local reaction force. Is this clear? Abhi I am not moving it, guys. Abhi this is at rest. Abhi this object is at rest, okay? Please write it till here. थोड़ा जल्दी जल्दी लिखो. A little bit theoretical chapter and a little bit numerical chapter. Guys, did you draw the diagram? This is not a definition or anything. It's just a story to make you understand that, why is the normal reaction coming into existence. Because, when this normal reaction was coming, nobody asked me, sir, why is it coming in contact? So, although obviously when, that question would have arisen, I will tell you to, go to the friction chapter. When I will teach the friction chapter, then I'll tell you about that. ऐसा करके बोल देता, but nobody asked the question. So, it's okay. It's my job to tell you things. Are you done writing? Guys, are you done writing?
Yes, sir.
So suppose this is one part of the section where I want to draw the normal reaction. The blue normal reaction which I'll be, can you see this is the point of contact, this is the point of contact, this is the point of contact. So can you see there are very few point of contacts are there. So here the normal reaction, let's say it is like this, so N1. Here the normal reaction it's like this, let's say N2. Here the normal reaction is like this, let's say N3. Here the normal reaction is like this, let's say N4. And here the normal reaction is like this, let's say N5. Are you getting my point? So can you see the blue normal reactions are basically the normal reactions which are acting on a points on the body, right? Right?
Yes.
Whereas on the ground, the same normal reaction will be acting in the opposite direction. So can you see the green normal reactions, guys? All the green normal reactions are basically acting on. Guys, what happened? Hello?
Nothing, sir.
Someone married? So basically these N1, N2, N3, N4, N5 are your local reaction forces. Are you getting my point? Now can you see, due to the irregularities, these local reaction forces are not perpendicular. The normal reaction which we draw is perpendicular to this surface, right? Yes or no? Yes or no, guys? So
Yes.
basically what I can do, I can resolve this normal reactions into two components. So can you see over here? I'll just resolve the blue ones, okay? So can you see the normal way, the perpendicular component, and let me just take another color. Let me take red. So I can, divide it into two parts. Divide it into two parts. Can you see I'm resolving it into two parts? Yes or no? Yes or no, guys? Let's say this is straight only. So can you see all the components which are perpendicular to this whole thing? Yes or no, guys? So all the components, all the vertical components their vector sum, all the vertical components of the local reaction forces is responsible for the normal reaction. So basically when you will take a vector sum of all these perpendicular ones, can you see the vertical ones? So all the vertical components of the local reaction force is responsible for the normal reaction acting on the body. Is this clear, guys? Is this clear, guys? So basically, can you see all these perpendicular components? N1 perpendicular, N1P, this is N2P, this is N3P. You don't need to write N2P, N1P, and all, right? N5P, N4 is that direction only. So basically the vector sum of n1p, n2p, n3p, n4, n5p. Are you getting my point? Can you see all of them will be pointing in the upward direction? So basically the sum of the vertical components is basically providing you the normal reaction. So that is why the normal reaction is there. Is this clear, guys? Now you understood the reason behind the normal reaction. Hello? Hello?
Yeah.
Yes, sir.
Is it clear? Now did you
Yes.
understood what is responsible for normal reaction? And what will be responsible for friction? The vertical,
So the vertical forces which are not perfectly perpendicular.
These N1, N2, N3, N4, the blue ones were the local reaction forces. You resolved those forces into two components. Whenever it is out of frame, you resolve it into two components. No? So you resolved that N1 into two components. One is N1 perpendicular and one is N1 parallel. So all the perpendicular components to this surface, so can you see all these vertical ones gave you what? The normal reaction. And all the horizontal ones, all the horizontal component of the local reaction force will give us friction. Is this clear, guys? What will provide you friction and what will provide you normal reaction? Is it clear? So this is
Yes.
when
Yes,
the
sir.
object is at rest. Please remember, note, when the object is at rest, all the horizontal components, cancel out each other, due to which the object is at rest. Yes or no, guys? Why is the object be able to be at rest? Because all these were horizontal component. Can you see? This one is acting towards left, right, and so on. Right? There will be millions of forces like this. So basically, all those horizontal component will cancel out each other, due to which the object is rest. Is this clear, guys? At rest, is it clear?
Yes, sir.
Okay. So now you understood the cause of normal reaction and friction as well. Now let's talk about what happens when one tries to slide over other. So case 2, this was case 1 when the object is at rest. Case 2, when the body is moving over the surface. So now guys, what happens when the body tries to move over another? When the body tries to move over the surface or move over the ground, then see what happens. When this thing will go down, will it happen like the crests of the body may lie on the troughs of the ground or of the surface, right? Is when they will slide over each other, does this thing can happen? Can this thing happen? The crest of the body may lie on the troughs of the surface and vice versa. Yes or no? Can this thing happen? When the bodies slide, over the ground, then will it happen like the crest of the body will lie on the trough? Will it like be forming an interlocking like this, right, guys? Hello, you understand what an interlocking is, right?
Yes, sir.
So due to this thing happening, interlockings are formed? Are you getting my point, guys? And when this body will try to move over this particular, the contact interlock, due to the interlockings, the contact point, these forces will increase, right? So even the friction increases at that time. So so due to this thing, the interlockings are formed. Now when these interlockings can be applied by some additional force, on the body, but certainly these interlockings will oppose the motion of the body on the surface. Is this clear, guys? So now you understood what is the cause, what is the cause of friction in case of two objects whenever there is a relative motion between the object, right? Because of the formation of these interlockings, guys. Because of the formation of these interlockings, there is friction offered between the two surfaces. Is this clear? Is this clear, guys?
Yes, sir.
So this is the cause of friction. So once you're done, tell me. Then we'll talk about the types of dry friction now. The questions on frictions are very interesting. Now we don't think like we'll not be using the concept of pseudo force or the spring string. Those will be still there. So please, that's why I'm telling you, I need the practice of those questions. Once you'll be done with those DPPs, I'll be giving you more. Until unless I want 4 DPPs minimum to be solved, then only I'll be able to teach you constraint relation thing. Okay? In case, I'll just remind you again, people. Let me go back to where the DPPs were. How do you reply on this thing? Forward to 11th grade online test again. What is the date on Friday? Friday is 17th in July. Kindly ensure solve the PPP. Thanks and regards. Okay. So quick reminder, guys. Please see the message in the group. Is it clear,
Yes.
guys?
Yeah.
When you will be done enough practice on NLM, then I can take one paper on NLM as well. And I want to take it by the end of this month, in which I'll give you NLM and friction together. Or do you want me to take NLM without friction separate or LNM with friction separate? You have choices for every type of thing. I'm giving you choices there. Anji, what do you want? Batao.
Sir, both separate.
Both separately. Take it.
Yeah. So is friction hard?
Friction is not hard. It's just one more force added to the FBD.
Okay.
But the nature of friction is like very bad. So to understand it clearly, it's like separate thing only. So generally people teach it like two different NLM separate, NLM with friction separate, NLM without friction, NLM with friction. It's like that. So anyways, reaction. What is the reaction force? It is basically the vector sum of all the local reaction forces acting between two objects in contact. So basically, suppose if this object is there, and let's say this object is trying to move in this direction with a velocity v, or it has a tendency to move. So when I do this, can I say this particular thing? Then this surface will try to oppose the motion of this object by applying a friction in this direction. Yes or no? Yes or no, guys?
Yeah.
Yes or no? There will be a normal reaction as well. Do you remember the normal reaction is basically the sum of the vertical components of all the forces? The horizontal component is basically friction, right? So basically, whenever you will be just taking the resultant of normal reaction and the friction, you will be getting something called as reaction force as well. So there is one more definition. It is the vector sum of normal reaction and friction acting on an object. Is this clear?
Yes, sir.
So basically, if I want to know what is this theta, then can you say tan theta will be equals to, what will be tan theta? Can you see a triangle like this will be formed? I think now you are familiar with making these triangles and all, right? N is over here, R is over here, F is over here. I can just take this vector from here and put it over here. I get something like this. So tan theta is basically F upon N. Is this clear? And can you see the angle between normal reaction and friction is always 90 degree. So R will be equals to under root of N square plus. Is this clear, guys? This is the total reaction force acting on an object. Is it clear? Please write this thing, guys, and just give me 2 minutes. I'll just be back. Guys, just give me 2 minutes. I'm getting a call from office. Hello.
Okay.
Guys, done? Hello, guys. Are you done?
Yes, sir.
Sorry. Write down heading. Types. It's a very small chapter. Please remember, guys, friction is very small chapter. It's not a big deal, But the problems which comes on friction, they are a little bit typical for beginners. But once you get the hang of friction, it becomes very easy. So don't worry. For getting the hang, we'll do lots of questions, obviously. So now you understood my strategy, no? Guys, did you understand my strategy? How do I teach physics? It's like I teach by teaching more and more numericals, but when you apply it more and more, automatically your concepts becomes good. Did you check your marks?
Yes, sir.
So checking.
So between two surfaces, the types of two solids.
It's dry and wet, right?
No, dry and wet to done. Between
That
two
was
solids. So this is basically types of dry friction here. Okay.
Uh-huh.
So types of dry friction. Now we'll draw a flow chart so that you'll be able to understand it much better. ये wet friction को let it be. So, or you can just classify them into one is static, one is dynamic. Okay. What do you mean by static friction? The friction when the object is at. Please remember, it is the friction acting on the object when there is no relative motion between the object. That implies the object is at rest. Hello. Static friction. Don't worry. I'll give you the definition at the time. Dynamic friction is when the object is in relative motion. Static friction, the maximum, there is one more friction in static friction which is called as limiting friction. Basically, what is limiting friction? It's the maximum value possible for static friction. It's the maximum value possible for static friction. But basically, this limiting friction is static only, but it is the maximum possible value, right? This dynamic can be in two different types. One is called as kinetic friction. No. Sorry. This is called as kinetic friction, dynamic or kinetic friction, whatever you want to know. Sliding. So there is one sliding friction. What is the sliding friction? Sliding friction is basically when one object slides over other, and there is one more friction which is called as rolling friction. Okay. So guys, and did you understand the hierarchy of friction, dry, wet, dry, static, dynamic, or kinetic? Sometimes people refer this as kinetic. Okay. Sometimes people refer this as kinetic. Okay, because in this whole chapter, this objects will slide only; they will not roll. So basically, wherever I use sliding friction, I can use the term kinetic friction as well. Okay, is this clear, guys? So these two terms I can interchange in this chapter. So if you want, you can name either this or that. Anyways, once you're done with drawing this thing, then we'll start with each and every one. We'll start with static friction first. Guys, are you done?
Yes, sir.
So let's talk about static friction first. What is static friction? It is the friction acting on the object. It is the friction acting on the object when the object is at rest, or either this you can write, or a simpler definition, it is the friction acting between object objects when they are relatively at rest with respect to each other. This is called as static friction. Is this clear? Is this clear, guys? Is the definition part clear?
Yes,
I think
it's
there's
clear.
Yes.
no need to explain this thing. नाम से समझ में आ रहा है static friction. Okay, or you can say relatively at rest. So please remember. Now, suppose I'll try to give you by example. Suppose, guys, there is an object which is placed over this rough surface. Okay, there is this object of mass m placed over this rough surface. Tell me, if I am not applying any force, is there any external force over here? Is there any external force over here? Guys, did I draw any force acting on this object mg? Mg and normal reaction are there, which will balance with each other. But is there any force which is trying to move this object m on the rough surface? Here in this case, no, right? So if f external is 0, so there is not even a tendency of an object of this object, not an object of this object to move on the surface, right? Yes or no? If there is no force, then there is no tendency also. So that implies even the friction acting on this will be zero, but this friction will be static in nature, right? There is no friction over here, but still, even if there would have been any friction, this friction would have been static in nature, right? So here in this case, friction is zero, and the object is at rest. So this is the first example. You need to understand this. Okay, guys. No external force, no static friction as well. Is this clear? Now, in the second case, if I say, if I apply an external force, if F is applied, and let's say if F is applied, then the number of interlockings will increase. I told you, okay, whenever you try to move it, the number of interlockings increase, right? So when the number of interlocking increases, if F is continuously increased gradually, even the static friction increases, right? Guys, tell me this particular thing. There is a heavy box in front of you. You need to push that heavy box on a rough surface. Will you be able to do that easily? Guys, tell me. If there was a heavy box in front of you and you want to push it, will you be able to do it easily on a rough surface? No, right? You will require a large amount of force. So first you'll start by applying lesser force, and gradually you'll increase the force to move that particular thing, right? So as you know, when you apply that particular force, the number of interlocking increase. If F is continuously increased gradually, even the static friction F will also increase till the time it attains a maximum value of friction. This maximum limit of static friction, which can be applied on the object. This is the definition, hai na? Which can be applied on the object nahi. Which can be applied, which gets applied. We are not doing it, no, it is happening on its own. So which gets applied on the body is called as limiting friction, denoted by Fm. So once you're done writing this point, then I'll explain you exactly what is happening in this case. Guys, whenever you're done, just tell me.
So 2 minutes.
Okay.
So wait, so if the max, no, like if I keep applying force and the friction increases to full
Yes.
maximum, right?
Yes. And after that, friction won't be able to increase even if your external force keeps on increasing. It doesn't mind. Then friction will no longer be static anymore. The object will start moving. It will become kinetic.
So what will happen then?
It will start moving, but friction will also be applied. Friction will attain that maximum value, and that maximum value will be constant. अभी मैं बता रहा हूँ ना, diagrammatic representation I'm giving you. Don't worry. Okay. I'm giving you a diagrammatic representation. Don't worry.
Okay.
Once you write this thing, then I'll give you the diagrammatic representation. Just tell me whenever you're done.
Done, sir.
Everyone done? Now see guys, let's say this is the same block and this is the same surface. And initially when the external force was 0, this block was at rest, right? Still we are studying static friction, so still it will be at rest only. So let us say the limiting friction, say the limiting friction is 10 Newton. Okay, guys, let us assume that the limiting friction on this block is how much? On this is how much? 10 newtons. Okay, so let's say if I increase the force from 0 Newton to 1 Newton, so what will happen? If this force enough to move this particular block? Can you see the maximum amount of friction which can be offered is 10 Newton, and I'm applying a force of 1 Newton in order to move this block. Will this block move? Will this block move? Yes or no? Hello guys, understand this thing very carefully. When this is basically the maximum value,
Maximum limiting friction.
maximum value of friction which can be offered.
From 10 Newton, then only it'll start moving.
So if F external is greater than this limiting friction, then only the object moves, right? Till that time, the object will be at rest. So please remember this thing. Can you see in this case, the external force I applied was 1 Newton, but the maximum limiting friction it can go is still 10 Newton. So to keep this object, will this object move? Will this object move or no? अरे yes or no, हाँ या ना, कुछ तो बोलो.
Yes, sir.
Will it move?
It won't.
It won't move. It won't move. Why it won't move? Because this external driving force is less than the frictional force. Here, if the object wants to move, if F external is less than the limiting friction, that implies the object will not, the object will still remain at rest. Are you getting my point, guys? So here your external force is not greater than the limiting friction, hence your object is still at rest, and to make this object at rest, the static friction which should be acting on this object should be 1 Newton. Then only these two forces will be balanced with each other. Yes or no? So can you see this thing, guys? If F was 1 Newton, even our small f was how much? The friction was static in nature, and this was the force. Is this clear? Is this clear, guys? The friction is
Yes.
still static in nature. The object is still at rest. I'll just draw it somewhere else so that you know. So first, in this case, please remember, if external force is greater than the limiting friction, then only the object will move. If F external is less than the limiting friction, then the object will not move, it will be at rest. Can you see the friction adjusted itself such that this object doesn't move? Okay. Sir, what will happen if I increase the force a little bit more? So let's say I increase the force till 4 Newton. Then what will this friction do? Is this external force still enough to overcome the limiting friction? Is this external force enough to overcome the limiting friction? Is 4 Newton greater than 10 Newton? Hello? Hello guys?
No,
Hello?
it's less. 4 Newton.
It's less. So obviously the object will not be moving again. So it will be still be at rest. To remain this object at rest, a frictional force of how much will be applied? 4 Newton. So when the force became 4 Newton, the friction also became 4 Newton. Till this time it is static, 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 right? Let's make it a little bit more. Let's make it 9.99 Newton. Let's say the external force is how much? 9.99 Newton. So what will be, will this object move still? Will it move? It
Yes,
will be
sir.
still at rest.
Yeah.
So still the friction will be acting and the friction will be static in nature and the
Fs is static force, right?
yes.
And static force applied when an object is not able to overcome the limiting force and it is at rest.
So then only the static friction will come into play.
Okay.
9.99 Newton and static friction is also 9.99. At these, all these cases, the friction was what in nature? The static friction. Is it clear, guys? Till F external is less than FL, till that time the friction is static in nature. Can you see this particular thing? Note, static friction can adjust its value according to the external force. Yes or no? So please remember, static friction can adjust its value, but always remember, in all cases it can adjust its value. Still the static friction should always be less than or equal to the limiting friction. Is this clear? Is this clear, guys? Static friction will always be less than the limiting friction. Now see what will happen when I apply a force equal to 10 Newton. So when I apply an external force equal to 10 Newton, then at this particular stage, the friction will become limiting the maximum value. How much? 10 Newton. So can you see over here, if F external becomes how much? If F external is 10 Newton, then our friction becomes limiting in nature, and this is also equals to, can you see, limiting. Is this clear, guys? So now still it is static only. Can you see, guys? Limiting friction is nothing but the maximum value of static friction. So can you see, the static friction has become maximum. So in this case, the static friction became max. At this stage, the object will neither be at rest, neither be in motion. It will be just about to slide. Are you getting my point, guys? It will be not in rest, not in motion. Basically, if you give an analogy, so this is basically your red light. Can you see, guys? Red light, not at all movement. This will be the yellow light, where the object is just started his car. Now, as soon as the green signal comes, it will move, right? Yes or no? Yes or no, guys?
Yes.
So till here complete, till here is static friction. Till where have you written? Guys, till where have you written? Did you write till here?
Yes, sir.
Yes.
No, sir. Yeah, fine.
We'll just discuss what will happen, the second case, kinetic friction, or basically the sliding friction, right? We'll just discuss that, and that's it for today in friction. In the next class, we'll teach you how to calculate this limiting friction, because this is the one thing which decides everything. If you know how to calculate this, then I'll teach you how to decide what will be the motion, whether this will move or not move. Are you getting my point? The basic concept should be clear. Whenever you are done.
Done, sir.
Okay. So till here, the friction will be static in nature. After this, what will happen? The friction will become kinetic, or here in this case, we are studying sliding friction. Okay. So either kinetic friction or sliding friction, denoted by F. Okay, we will not denote it by Fs. Why? Because we used Fs for static, right? Is this clear? So when the external force applied, or generally the external force is called as basically the driving force. So when the driving force is greater than the maximum, greater than the maximum value of static friction, maximum value of static friction basically called as, so when the driving force is greater than the limiting friction, then the object no longer remains no longer remains at rest, and it starts accelerating in the direction of the driving force. Please remember, what is the driving force? Driving force is nothing but your F external. Okay, so basically what will happen, suppose if this is the case when you have this object on which this is the F external, and this was the direction of the friction, right? If I give you this condition, if F external is greater than the limiting friction, that implies object is no longer at rest. That implies friction becomes kinetic. Okay, is this clear, guys? Can you see the nature change of the friction? So here the friction will no longer be FL, it will become FK. Are you getting my point? And this object will start accelerating in this direction. What will be the direction of, what will be the acceleration? Acceleration will be equals to F external minus Fk divided by the mass of the object. Yes or no? Well, this is how you will calculate the mass. This is not a formula, by the way. Please remember, this is just suiting for this example. Okay, is this clear, guys? Can you see the driving force minus the kinetic friction? Is this clear?
Yes, sir.
So please write it fast. No, it will just give me two more. One, last note I need to write, or we'll write the note in the next class. So basically, if what was the fourth? What was the fifth? Now fifth, na? So can you see in the previous example, the fifth case, if I draw it like this, if suppose this is the object and now I've increased the force from your limiting friction. So F is equals to, let's say, 12 Newton. So can you see here, the friction will not become kinetic in nature, and this will be 10 Newton.
12 Newton, right?
12 Newton is the external force. Do you
Of the
remember
friction.
the limiting friction of 10 was 10 Newton? The friction
Yeah.
cannot get its value greater than 10 Newton. So the maximum it can do, it did. Now it
The net,
cannot. Are you
matlab
getting
the
my point?
net force by which the block will move is 2 Newton.
Exactly. So basically, A net will be equals to 12 minus 10
2 by
divided by
m.
whatever the mass of the block is. Let's say 2 kg. So 2 kg. So then now the block will start moving with 1 meter per second. Are
So
you
basically,
understanding my point, guys? Is this clear? In this case, the object will start accelerating on this block. There will start, the relative motion between the objects will start. Is this clear?
yes, sir.
Guys, is this clear?
Yes.
It's easy, sir, except the formula like on top.
It's the same thing, but this formula is basically what, the Newton's law, the bigger force minus the smaller force divided by the mass is basically the acceleration. Yes or no? A bigger force minus smaller force is equals to mass multiplied by acceleration. It's one and the same thing. It's second law of motion, right? It's not a formula, but the second law of motion was a formula. This is not a formula which we are writing over here. This is not a formula. Okay? Is this clear, guys? Chalo, in the next class we'll continue after this. We'll make you write one point about kinetic friction and as well as rolling friction, I'll tell you. And then we'll draw a graph of whatever we discussed over here. And then that's it. That will be over. Then we'll start with the problems. And we need to do after that the laws of limiting friction. You need to calculate that limiting friction. So in the next class, it will be something more additional. So is this clear, guys? I'll send you these notes as it is. We'll see you again in the next class then.